All right, the composition of functions. It's a great topic, something that is super useful in mathematics, not only in algebra, but when we get to calculus, quite important and beyond that. So the composition of functions is basically this idea of starting, with like an x value, okay, and applying some function to it. Let's say that we apply some function g to it. And so remember what that function does. That function, takes that x value and assigns a rule to it, whether it squares it, adds 2 and divides by 4, whatever it does, that's what g of x is going to do, or g is going to do. And what happens then is x is going and is being mapped to some value g of x, which we consider like a y value. And then what a composition is, then we have this other function coming along. Let's call this f, and we apply this function f to the result of what g has done to x. And this is what we call a composition. It's where I compose two functions together on some point x. So we have more than one function going into play here. A lot of times, it's going to be a lovely drawing. You can think of a composition as like a machine where you spit out, right, some product, let's say g of x, and then that machine takes, this is a lovely drawing. Then that whatever that machine spits out, this g of x, that g of x is then put into this machine f, and f applies to the result. That just clears it up right there. I mean, I don't know why you would have any issues with composition after seeing that beautiful beautiful picture. So some ideas of composition, like when we do maybe temperature changes. So, there's Fahrenheit, Celsius, and Kelvin, and there's a relationship between Kelvin and Celsius, but there's not a relationship that we really look at for Kelvin and Fahrenheit. So if I wanted to take something that was like 45 degrees Fahrenheit, I would first have to change it into Celsius, and then I would change it into Kelvin. So this is a function and this is a function, and that's an example of composition. We don't have state taxes in Wyoming, state income tax in Wyoming. But if you live somewhere else, like I lived in Colorado for a long time, I grew up there, we have state income tax. So when you go to calculate your state income tax, you first calculate your federal income tax, and then your state income tax is going to be a function of the result of your federal income tax. So that's also an example of composition. Composition happens a lot, and it's super useful. So let's write this down, and just a little bit. I'm so sorry, but I'm gonna have to erase that machine picture. I know, I'm sad too. That was just beautiful. I should switch and start teaching art. I'm pretty sure I've missed my calling. I am definitely not an artist. My poor children, when they ask me, my 5-year-old will be like, "Mom, draw me a cat," and I'll draw her a cat. And she's like, "No, I said a cat." And I'm like, "That is a cat. I don't know how to draw a cat, okay? Ask me to draw you a parabola or something." So so we're going to kind of define a new function here. We're going to call this the composite function. So the composite function, and what this composite function, here's some notation we're going to use. We're going to use f composed with g. So that's what that little circle means. This means composed with. It does not mean multiplication. Listen to me. It does not mean multiplication. It does not mean multiplication, okay? So that circle there is we're kind of defining a new operation here, and it does not mean multiplication, people, so don't do it. Don't you dare multiply. So the composite function f composed with g, is another way to think of that is the composition of f and g. So that's another way we can say it. Of f and g is defined as, okay, so here's how we're going to write this. F composed with g of x. See how that's a new function? So it's a function of x. And here's what f composed with g of x is going to give us. I'm going to do f of g of x. So you're going to kind of work from your inside out. So when you have f and then g, that means that I have f of g. I can write this the other way. I could do g of f, and then what that does is switch the order right here, okay? A couple things about x. This is where x is in the domain of g, right? So remember, g is inviting x values to the party. And if you notice here, if you look at how this was written, here's my x value. What function is applying itself first? It's g. So if there are any x values that g can't handle, those x values aren't considered even with the composition. Think about that again. G gets to go first, right? G gets to have the first try at inviting people to the party. Okay, so G, if there are any x values that are going to cause issues like division by 0, something like that, negative under the square root, G will not invite those x values because G is going first. So x has to be in the domain of G. And then what is F? What is F doing? F, what is F? What are we taking F of? We're taking F of G of x. So whatever that number is right here, people, that number better be in the domain of f also, right? So if I get like g of x to be 0 and f happens to be 1 over x, then I'm not going to be able to do 1 over 0. So we have to consider the domain a little bit. It's going to be a little bit weird. But x is in the domain of g, and g of x, it's not weird. I don't know why I call it weird, is in the domain of f. Okay. Let's see here. Good. So we just need to let's do some examples, all right? Because that's what we should do. We should do some examples. All right, example. Let's let f of x equal 2x minus 5 and g of x equal x squared minus 3x plus 8. And we're just going to go crazy here and find a bunch of compositions. So let's find f of g of x. All right, so I'm going to take f of g of x. So when in doubt, I really recommend you go back and look at what this definition is. So write this down each time if you're not sure what's happening, okay? Wrong layer. Oh, look at that. I wrote that in that layer. So I went back and I rewrote my definition. Okay, f of g of x. All right, and so what does this mean? So a couple ways to think about this. Whoa, we're getting crazy with the yellow here. What this means, so a couple ways to think about this. I'm going to look at what is g of x, right? Well, I know g of x is this x squared minus 3x plus 8. So I'm actually just going to write in here x squared, right, minus 3x plus 8. So remember, x is going in. What is g of x doing to x? It's doing this rule right here, which is x squared minus 3x plus 8, okay? So this whole g of x I've just rewritten, right? F of g of x, so I've just put in g of x right here. And what does it mean to take f of whatever this is? It means everywhere I see an x in my function f, I am going to put what's in the parentheses. What's in the parentheses this time? X squared minus 3x plus 8. I hope that makes sense. Remember, if I asked you, let's just do a little, to find f of 1, right, what would you do? You'd put a 1 in for x. What if I asked you to find f of smiley face? You'd be like, well, Sarah, that's silly. And it is, but I'm trying to make a point here, which sometimes comes across and sometimes doesn't. F, whatever is in the parentheses is going to replace that x. So do you see whatever is in the parentheses is going to replace that x right there. Now I can just simplify. I'm going to take the 2 through minus 6x plus 16 minus 5. And so we get 2x squared minus 6x plus 11. Okay, I hope that makes sense. I'll give you a bit of a warning here. I might have to put this video in 2 parts because my computer is only letting me go for 10 minutes, it looks like. So we will pick this right up with the second part, hopefully, if it allows me to bring this up. So if I get cut off all of a sudden, then please just look for part 2 of this video. Sorry about that if that happens. My computer thinks it's up on space and it's not, but that's okay. Neither here nor there. All right, so let's look at switching these to the G and the F, and let's see what happens if I switch that order, what that does to my composition. Okay.